Our story begins billions of years ago, long before our own sun graced the cosmos. A massive star, much larger than our own, reached the end of its life. It exploded violently as a supernova, scattering its enriched guts across the galaxy. This explosion sent a shockwave, a ripple of energy traveling through space at incredible speeds. This shockwave slammed into a nearby cloud of gas and dust, a nebula, disturbing its peaceful existence. The force of the impact caused the nebula to collapse in on itself, pulled together by the irresistible force of gravity. This marked the beginning of our solar system, a cosmic nursery where stars and planets are born. This collapsing cloud, now called the solar nebula, wasn't just sitting still. As it contracted, it began to spin faster and faster, like a figure skater pulling in their arms. The spinning motion caused the cloud to flatten into a disk, with most of the material concentrating in the center. This central bulge, under immense pressure and heat, would eventually become our sun. Deep within the heart of the collapsing solar nebula, the temperature and pressure continued to soar. Atoms of hydrogen, the simplest and most abundant element in the universe, were squeezed together with unimaginable force. This intense pressure overcame the natural repulsion between the atoms, forcing them to fuse. This process, called nuclear fusion, released an incredible amount of energy in the form of light and heat, and with that our sun was born, a blazing ball of plasma, illuminating the surrounding disk of dust and gas. The sun's ignition marked a turning point in the evolution of our solar system. Its powerful gravity now dominated the surrounding disk, shaping the destiny of the material swirling around it. The stage was set for the formation of planets, our own Earth among them. But the early solar system was a chaotic and violent place, a far cry from the relative peace and stability we observe today. The solar nebula, now bathed in the light of the newly formed sun, was teeming with tiny particles of dust and ice. These particles, remnants of the original nebula and enriched by the supernova explosion, were the building blocks of future planets. Through a process called accretion, these particles began to clump together, drawn by their mutual gravitational attraction. As these clumps grew larger, they attracted more and more particles, snowballing in size. These growing objects, called planetesimals, were the precursors to planets. The inner region of the solar system, closer to the sun, was much hotter than the outer regions. This difference in temperature played a crucial role in determining the composition of the planets. In the inner solar system, only rocky materials like iron and silicate could withstand the intense heat. These materials formed the terrestrial planets: Mercury, Venus, Earth, and Mars. Further out from the sun, where temperatures were much cooler, a different kind of planet formed. Here, in the frigid depths of the solar system, water ice and other volatile compounds could exist in solid form. These icy bodies, along with rock and metal, accreted to form the gas giants: Jupiter, Saturn, Uranus, and Neptune. These massive planets, with their powerful gravitational pull, would play a crucial role in shaping the early solar system. The early solar system was a chaotic and violent place. Planetesimals and protoplanets, still in the process of forming, collided with each other at high speeds. Some of these collisions were catastrophic, completely obliterating the colliding bodies. Others resulted in mergers, forming even larger objects. One such collision between the early Earth and a Mars-sized object called Theia is thought to have formed our Moon, a defining moment in Earth's history. For the next episode of the history of our universe, follow astrogees.com.